I always start with this to find the derivative because you guys know what a limit is. We just did a whole chapter on a limit. And it's probably the longest, it's definitely the longest way to find a derivative. So once I show you the short ways, you're not going to want to go back to the long way. So I always start with the long way, and then tomorrow I'll show you shorter ways. I'll show you rules, what we call rules for differentiation, for finding derivative. Okay? So we have a bunch of different symbols. Remember from yesterday, f prime, y prime, dy dx. All those blue guys signify a derivative or a derivative equation, right? D dx means an action. I want you to do this. I want you to find the derivative, okay? So if you see the word derivative, that's what it means, slope of the tangent line. If you see the word differentiate, it just means find the derivative. They both mean the same thing. One's just a noun and one is a verb. Okay. One says, this is it. One says, I want you to find it. Okay. So that's just differentiates an action, a verb. Derivative is a noun. Okay. All right. So let's go to the last one that we haven't done yet. Example number 4. So we have to find, now what we have to find is what's called the equation of the tangent line. Okay. So equation of the tangent line. All right, so let me highlight some stuff here. Equation of tangent lines. We know what a tangent is, right? Tangent is those blue guys. Touches the graph in one spot. Okay. It's a line. What do we need to find equations of lines? What do we need to find equations of lines? We need points, right? So points are important. Let me write this down. We need points. At least one, but more than one would be nice. What else do we need to find equations of lines?
The y-intercept.
We could have the y-intercept. We don't, yeah, there's ways around that, but if we get the y-intercept, that would be nice. There's a biggie that we haven't, that we need, slope, right? If we know the y-intercept and we know the slope, we can use slope-intercept. If we don't know the y-intercept, but we know a point and a slope, we can use point-slope. Either way, though, we need the slope. Okay, so we need the slope. So the first thing I need to do is find the slope of the tangent line. That's a derivative. That's a derivative. Slope of the tangent line is a derivative. So the first thing I need to do is find the derivative. Okay? So let's set it up. Move this down a little bit. The limit as h approaches 0. Okay, we got h on the bottom. H is always on the bottom. Then we have a subtraction sign up here. The function f of x goes second. So I'm subtracting all of it. So I put it in parentheses. I'm not just subtracting the first x squared, I'm subtracting the whole thing. And then we have this yellow stuff here, right? That needs to go there. We talked about this yesterday. How do I get that? I know this part here, right? This part, the blue is just the original function. So ours is x squared minus 4. How do I get the yellow? What did I do yesterday? What did we do yesterday to get the yellow? So anywhere I see an x, I'm going to plug in this guy here. That's what that means. Plug in this anywhere I see an x. Okay. So let's go down to anywhere I see an x. The only place I see an x is right there. So instead of x, I'm going to write parentheses x plus h squared. Negative 4 doesn't have an x, so it's just going to be negative 4. Okay. It's a limit, so plug in 0. So if I plug in 0 for h, I get x squared minus 4 minus x squared plus 4 over 0. Because if I plug in 0 for h, 0, so I plug in 0 there, so I would just get x squared minus 4. And then if I distributed this, I would get minus x plus 4. X squareds go away, 4s go away. That leaves 0 over 0. And we talked about this yesterday. We've talked about it last chapter too. If we have 0 over 0, that means there's work left to be done. There's stuff left to be done. Well, this kind of looks like one of the ones we did yesterday, right? It kind of looks like this guy here, x squared. So yesterday what we did was we multiplied that binomial, x plus h squared. That's what I'm going to do now. So what I'm going to do is I'm going to multiply this guy. I already did it yesterday, so I don't need to do it again. What happens when I multiply that guy? What did I get yesterday? I got x squared plus 2xh plus h squared. All right. And then I can distribute here. Negative x squared plus 4, and then h just stays h on the bottom. Okay. So now let's see what we got. Okay, so x squared and x squared go away. Oh, whoops, I forgot to put a negative 4 in there. This negative 4 here, I forgot to put this negative 4 there. Should have also been in there. Okay. So those guys will go away as well. Thanks. Okay. So let's see what I got left. What I got left is the limit as h approaches 0, 2xh plus h squared over h. That's what's left. If I plug in 0, I'll still get 0 over 0 because I'll have 0 plus 0 squared on top over 0. So I still have 0 over 0. So what was the thing that we talked about yesterday? What was the thing that we could do? Factor, yeah. Because they all have h's. So I'm going to factor out an h. H, 2x plus h over h. The h's become 1s. So I'm left with the limit as h approaches 0 for 2x plus h. Now when I plug in 0, I get an answer. The derivative is just 2x. Okay. So now that's not a slope. That's what we call that's a tool to help us find the slope, right? It's a tool to help us find the slope. So we're going to use that guy to find the slope. Okay. So let me get another sheet here. Okay. So I know that the equation is 2x. Okay. I need to find the slope at positive 12. So that means I'm going to use this guy to find the slope. So I'm going to plug in 12, and I get 24. That means the slope of the tangent line at 12 is 24. Okay. So we said we need a point or points, we need a y-intercept, and we need a slope. So far we got the slope. I got the slope. So now I either need the y-intercept or I need points or point to use one of those two guys. Which would probably be easier to find, the y-intercept or just 1 point? 1 point, yeah. Probably 1 point. So I know half of it already because x is 12. I got to find the y. How do I find the y coordinate when x is 12 for f of x?
Just plug in.
Plug it into f of x, right? Yeah, just plug it in. So what I'm going to do is I'm going to plug in 12 to f of x. So I get 144 minus 4 equals 140. So the y value at 12 is 140. There's my point. I have my point. I have my slope. I'm going to put them together now. So I get y minus y1, that's 140, equals slope times x minus x1, which is 12. Doesn't say which equation they want you to use, so we're done. That's the slope of the tangent line at 12. If I was to graph that line, I'll show you. Let's see here. So we have y equals x squared minus 4. Thank you. Minus 4. And then we have y minus 140 equals 24. Parentheses x minus 12. It's hard to see because the blue line is the tangent line. Right there is where they're tangent to each other, which is at 12. This is 10 right here, that's 12. It's very, very, it's almost a vertical line because 24 is a very big slope. So that's what we found. Okay. All right. Before we start our assignment, I want to give you another one to do on your own to try while we're working together. Let's see. So find somewhere to do this. There's not a lot of room on the notes because there was only one page, but find some room and I'll give you one more. Okay, call this example number 4. Or 5. 5. Okay, so I want you to find the slope of the tangent line for f of x, 2x squared minus 3 at the point 2, 5. Okay? So f of x is 2x minus 3. I want you to find the slope of the tangent line at the point 2, 5. Tell me what the slope is going to be. You don't have to do the whole equation, just the slope. I'll give you the answer so you can check on your own. The answer is 8. Okay, so in the orange, I plugged in x plus h. So I rewrote it. I rewrote the original f of x. Just instead of x, I wrote x plus h. And then in the blue, I just rewrote f of x. That's the original equation. So this part right here, this x plus h squared, we've done it probably 3 times already, so we know what the answer is. It's going to be, when we multiply it out, it's going to be this. X plus h times x plus h. And that's where I stopped for right now. Okay, so now I have to do some distributive property. Distribute the 2 here, distribute the negative here. So I have the limit as h approaches 0, 2x squared plus 4xh plus 2h squared minus 3, and then negative 2x squared plus 3. When you do this, things should cancel out. They should cancel out, especially things with only x's. 2x squared, negative 2x squared, negative 3, positive 3. The things with h's will stay. Okay, so let's see what we got left. The limit as h approaches 0, 4xh plus 2h squared over h. That's all that's left. Factor out h. So I get the limit as h approaches 0. Don't even need a denominator anymore because it's just 1. I get 4x plus 2h. Plug in 0 for h, and you just get 4x. So the derivative is 4x. Now that's not a slope, that's just the derivative equation. To get the slope, now we have to plug in 2. 2 for x. And you get 8. 8 is the slope of the tangent line. So first you have to find the derivative equation, and then you plug it in if it asks you. Okay? Like I said, this is by far the longest way to find a derivative. Tomorrow, we're going to kind of investigate to see if there's quicker ways to do it. And there are. Okay? So this is not how the whole chapter is going to go. This is just for today. So on the worksheet I put on you, first thing you're going to do is number 2, cross out number 2. Number 2 talks about the alternate definition. We don't do alternate definitions. We just do the original limit definition, which is this one here. So you don't have to worry about the alternates. Number 2, just cross out. I forgot to cross it out when I make copies. Okay? So what is the original limit definition of the derivative? It's right here. This guy right here. That's what that is. And then 3 and 4, you're just going to do the same thing. And then on the back, it's same thing. They kind of turn the tables a little bit and they ask you different questions. It's more of a